The question is, there are two bodies are given like this. This is your body A, and the second one is your body B. Body A and body B. And in this question, it is saying that make these bodies, make these spheres permanently. Make these spheres permanently charged using induction method, right? Using induction. Okay, this is our question. There are two spheres are given, sphere A and sphere B, and saying us that make these spheres permanently charged using induction method. Are you clear? Now, how can we make these two spheres charged? Are you okay? Let's consider that these two bodies are kept in contact with each other. Suppose, okay, this is your solution. Kept these two spheres in contact with each other. This is your body A and this one is your body B. Okay, body A and body B. Okay, and now what will happen? Suppose that if you are carrying a positively charged rod, if we carrying a positively charged rod near this body, in this case, you can look that, suppose that we are carrying a positively charged rod, okay, then the charge present upon these two bodies, then the charge present upon these two bodies are gets polarized, okay? Causing of this positive charge body, the negative charges are arises nearby the positively charged rod, whereas the positively charged are arises at the far point. Are you clear? This is your body A and this is your body B. And now what we are going to, okay, and now what we are going to do? Now in this case, first of all, there are two things, okay? There are two things which is important to notice here, that after polarization these charges upon the bodies, okay, how can we use separate these two bodies? The first of all, it's important to remember here that you never take away this positively charged rod first, okay? Keep this charged rod at the same position, but make the separation between the charged bodies first. Are you clear or not? First, we are going to separate the bodies, not the positively charged rod. Okay, this positively charged rod is as it is are present. The negative charge are present upon body A, okay, towards the positive charge rod, and the positive is laying at the far point. Are you clear? Now you can look at here. The positive charge rod is now at sphere A, and the negatively charged rod are appears at the sphere A, and the positively charged rod are appears at the body B. Are you clear or not? And now you can separate these. Now you can separate this rod. Now when you are going to separate, then what will happen? This happen that it happens that bodies are separately charged and the charge available upon the bodies are uniformly distributed. Are you clear or not? Are you clear or not?
Yes, sir.
Yeah. What we are okay, what we have to do here, first of all, we have taken the two spheres, both are neutral. Are you clear? Then for the permanently charged, we are carried out a positively charged rod near the bodies, okay, after keeping in contact with each other. Then due to this positive charge rod, the charges available upon the bodies A and B are gets polarized. Are you clear? After polarization, first we have to do the we have to separate the two spheres from each other, and then we will remove this rod. Are you clear or not? What will happen if you remove this rod first? If you if you have removing these bodies or this rod first, then the positively charged and negatively charged are once again distributed in such a way that they becomes neutralized, the just like these bodies. Are you clear or not? So it is important to remember here, before separating or before removing the positively charged rod, you have to separate the bodies A and B first. Are you clear or not?
Yes, sir.
All of you are clear or not?
Yes.
Okay. Sometimes it is also, remember here, sometimes what will happen, suppose that you have not removing you, suppose that sometime it's all it is also happens that, just 1 second, it's also happens here that these bodies, after removing the rod, these bodies are kept near each other, kept near each other. In this case, what will happen again, after removing the rod, the negatively charged are start appear at this edge, and the positively charged rod start to appear upon this edge. Are you clear or not? Causing which the force of attraction between two bodies arises. Are you clear or not? The force of attraction or attractive forces are arises. Okay, then you have to separate these bodies at the sufficient separation that the attraction is not appear. Are you clear or not?
Yes.
Are you clear or not? Hello?
Yes, sir. Yes, sir.
Yeah, all of you are understanding this point or not?
Yes, sir.
Okay, please note it down. All of you have noted down or not?
No, sir. Wait.
Sir.
Yeah, please do. Okay, please do fast.
Done, sir.
Okay, good. Now, should we move on?
Yes, sir.
Okay. The next heading is earthing. What is the earthing? What is the earthing? Earthing in the sense, in case of physics, that we are making the potential of the system is zero. Are you clear? What is the means of the earthing in case of physics? In physics, earthing in the sense, we are making the potential of a body is zero. Are you clear or not? This earthing is also known as the grounded conductor. This earthing is also known as the grounded conductor. Okay. Now please write the definition of the earthing. Earthing occurs earthing occurs, sorry, earthing means, just 1 second. Earthing means that the potential in the level, okay, potential means level, okay, or you can say potential also. Are you clear? The potential of a conductor has been made equal to 0. Has been made equal to 0. Are you clear? Suppose that you have a reservoir like this. Suppose that you have a big type of reservoir just like a sea, okay? Or you can also consider a sea. This is the sea and you are dropping, sorry, and you are, just 1 second. Yeah, this is the sea and you have some amount of water in this container. Suppose that, and you are transferring this amount of water from this container to the sea. Are you clear? Then can you tell me in what amount the level of the sea will rise? Can you tell me? This is the sea and you have some amount of water in your bucket. Are you clear? You are pouring this amount of water into the sea. Then can you tell me, does the level of the water in the sea will rise or not?
Yes, sir.
I think no. No
No,
doubt
because it
will
won't make
rise,
an
but it
effect.
is okay, infinitely small amount. So suppose that the level of the sea is this. After pouring this amount of water into the sea, the level does not change. Are you clear or not? And now let's take the another way. What will happen if you connect a river from the sea? Does the level of the sea will rise or not? I think it may be, okay, in very small amount. Are you clear or not? Because sea is a, sorry, the size of the sea is very large. Are you clear or not?
Yes, sir.
Yeah. So the level of the liquid, this level of liquid, okay, which you are seeing here, may be nearly 0. Are you clear? Level of liquid is still 0. Okay. Such like this, we make the bodies, okay, sorry, the potential of the body 0, because the earth is a big reservoir of the charge. Are you clear or not? In your houses, you have already know in each of the socket, you got a neutral wire. Are you clear or not? Or you can also say the earthing wire. Okay. What is the reason of this earthing wire? Because in case of leakage of current in any time, are you clear or not? In okay, such like in the rainy season, there is a leakage of electric current. Okay. So if there is a leakage of current, then what will happen? If the earthing is available, are you clear? Are you understand it or not? If the earthing is available, then through the earthing, the charge go to okay, the charge get transferred from the board to the ground. Are you clear or not? So you are safe. There is no any. Are you understand or not?
Yes, sir.
Are you
Yes,
clear?
sir.
What is the means of earthing here? We are making the potential of the body is 0. Okay. We are making the potential of the body is 0. No matter in what amount the charge the body have. Are you clear? If we join the conductor to the earth, then the whole charge of the body gets transferred to the earth body. Are you clear?
Yes, sir.
Okay. Now, please note down, earth is a reservoir. Earth is a reservoir having infinite charge. The second point, potential of Earth is 0. Potential of Earth is 0. Okay. And when the conductor gets Earth, then potential of that Earth conductors also be 0. Okay. So please also mention here potential of an Earth conductor. Potential of an Earth conductor is 0. Okay. And now what is the fourth point? Potential of Earth. It is also remember here. Potential of Earth and human body is same. And both are considered to be at 0 potential. Okay, please note it down. Have you noted it or not?
Done, sir.
Should we move on?
So it's a wait. Please
Okay.
just wait.
No issue.
Okay, done, sir.
All right. Let's take some examples. We have a body of positively charged. Suppose that we have a body of positively charged. In the second step, we are going to connect this body. Just 1 second. This is your body and this is your insulated stand. Are you clear? I mean, the charge can't transfer through this way. Are you clear or not? This is your insulated stand. Okay. And now we are connecting this body to the earth surface. We are connecting this body to the earth surface. What will happen? The body have already a positively charged, and now we have already know positively charged can't move. Do you remember or not from the previous classes? Naval, Alina,
Yes, sir.
all of you are remember from the previous classes.
Yes, sir.
Positive charge can't move. Why? Because these are tightly bounded with their with their nuclei, okay, or with their atoms. Then what will happen? From Earth, this body start to attract some positive, some negatively charged. Okay, I mean the negative charge start to flow from earth to the body, and this body gets negatively charged. And in what amount this body gets negatively charged? In the amount of the positively charged. And after gaining these negatively charged, the body becomes neutralized. Are you clear or not? I mean, now there is no charge is available upon this body. In this way, we can say that now the potential of the body is zero and the charge upon the body is also zero. Are you clear? Are you clear or not?
Yes, sir.
Yeah. Why? What is the reason to becomes potential? Sorry, to become the potential is zero and charge is zero, because the positive charge can't move from their parent nuclei, causing which this body start to attract the negative charge from the Earth's surface. Okay, causing which the negative charges are transferred from Earth to the body until the positively and negative charge are not equal. Are you clear? After this they get neutralized. Are you clear? Then we can say the potential of the body is zero and the charge upon the body is zero. Are you clear? It is also, remember here, if the charge upon the body is zero, is not means that the potential is zero always. Are you clear? It is also possible that body have no charge, but the body have some potentials. Are you clear or not? It is not true in all conditions. Understand?
Yes, sir.
Are you understand or not? It may also possible that body have no charge, but the potential is not equal to zero. Are you clear or not? It is also possible. Okay?
Okay, sir.
Yeah. And the next example is that we are taking a negatively charged body. Okay? And now we are connecting this negatively charged body to the Earth surface. Then what will happen? What will happen here? This body is connected to the Earth surface. Okay? And now the Earth body have already positive charge also, causing which the electron start to transfer to the Earth. Okay? After some time, the total electrons from the body are transferred to the Earth's surface. In this case, the net charge upon the body will be zero, and hence we can also say the potential is also zero. Are you clear or not? In both of these two cases, okay, we can see how can we make a body, the potential of the body is zero, or how can we make the earthing of a body. Are you clear?
Yes, sir.
Yeah, please note it down. Should we move on?
Yes, sir.
Okay. Now the concept of charge is over. And we have entered in the next part, Coulomb's law. Do you know about the Coulomb's law? Do you know about the Coulomb's law? Hello?
Yes, sir.
What is the Coulomb's law? Can anyone tell me?
Force between two charges.
Coulomb's law is helps us, okay, to calculate the amount of attraction or repulsion between the two charged bodies. Are you clear? What is the significance of the Coulomb's law? It helps us to calculate the magnitude of force acting between two charged bodies. Are you clear or not?
Yes, sir.
Are you clear? What is the significance? Can anyone tell me? Naval. Matthew.
It helps us find the
Yeah.
the repulsion and
No.
attraction.
It gives the magnitude of force.
Oh, okay.
It gives magnitude of force between two charged bodies, no matter it is repulsive or attractive. Are you clear?
Yes, sir.
Yeah. And now the statement of the Coulomb's, and now, sorry. The second point is that, okay, the both of the charge should be point-like. Are you clear? The both of the charge body should be like a point-size body. Are you clear?
Okay, sir.
Now, the Coulomb's law gives magnitude of force acting between two charged bodies. Are you clear? The one of the important condition, okay, is that the bodies should be charged. Are you clear? If the body is not charged, I mean the body have no charge, then the Coulomb's law can't be applied. Are you clear? Okay.
Yes.
Yeah. And now let's write the statement. Okay. What is the statement of the Coulomb's law? It states that the force of attraction or repulsion between two stationary charged body is directly proportional to the product of the magnitude of charge and inversely proportional to the, just one second. Let's write first like this. F is directly proportional to Q1 and Q2. Okay, suppose that you have two bodies like this. Sorry. Like this. This is your body Q1 and this is your body Q2. The magnitude upon the body A is Q1 and the magnitude upon the body B is Q2, and they are separated at R separation. Okay. then the magnitude of the force acting between two charged bodies is directly proportional to the magnitude of charge present upon the body and inversely proportional to the square of the distance between them. Means F is inversely proportional to the 1 over R square. This is your equation 1. This is your equation 2. Please note it down. Okay. Then we are going to solve it. Okay. Please note it down first. All of you understand this statement or not?
Yes, sir.
Yes.
Yeah. What is the statement is okay telling you? It tells us only the force of attraction or repulsion between two stationary charge body is directly proportional to the magnitude of the charge present upon the body and inversely proportional to the square of the separation between them. Are you clear or not? Okay, it is a statement
Yes,
of the
sir.
Coulomb law. Please note it down fast. Should we move on?
Yes, sir.
Yes, sir.
Yeah, okay. Remember that we got the two equation. F is directly proportional to Q1 and Q2 and F is inversely proportional to the R square. Okay. I am going to draw once again. This is your body Q1 and Q2. Sorry, 1 and A and B having charge Q1 and Q2. This is your body A, charge Q1, body B, charge Q2, and the separation between the bodies are R. Okay. And we got the two equations. F is directly proportional to the magnitude of Q1 and magnitude of Q2. And the second equation is 1 over R square. Okay, this is the equation 1 and this is the equation 2. From 1 and 2, if you try to combine these two equations, what you get? F is directly proportional to the mod of Q1, mod of Q2 over R square. When you remove the proportional sign, you got a constant K. Okay, mod of Q1, mod of Q2 over R square, where, sorry, R square, F is equal to, what is the K? K is 1 upon 4 pi epsilon naught. 4 pi epsilon naught. 1 upon 4 pi epsilon naught Q1 Q2 over R square. Okay, please note it down. Where K is equal to 1 upon 4 pi epsilon naught we have taken. Okay, this is your constant quantity. Remember that it's always be in international system. Okay, and now the value of K. What is the value of K? K is 1 upon 4 pi epsilon naught square, which is equal to the 9 into 10 raised to the power 9. So you can also write this equation like F is equal to 9 into 10 raised to the power 9 Q1 Q2 over R square. Q1 Q2 over R square. Are you clear or not? This is especially for the SI system. Okay, in SI system in the sense international system of unit. Are you clear or not?
Yes, sir.
Where this is your epsilon naught. What is the this sign? This sign is said to be the epsilon naught. What is this? Epsilon naught, or sometime some students are also said to be the epsilon 0. Are you clear? This is known as the absolute permittivity. Absolute permittivity of free space. You can say absolute permittivity of free space or absolute permittivity of air or vacuum. Okay, free space. What is the means of free space? Air or vacuum. For those for these two medium. Okay, for these two medium you can say it's a free space. And what is the value of epsilon naught? And upon this factor, upon what factor the epsilon naught depends on? So remember that the value of epsilon naught depends on the nature of medium. Are you clear? The value of epsilon naught depends on the nature of medium separating the charges. Okay, separating the charges. The value of epsilon naught is 8.85 into 10 raised to the power minus of 12 Coulomb square per meter square per Newton. Okay, please note it down. Then we will go to the understand about this point, permittivity. Okay, permittivity and the nature of medium. Okay, please note it down first. Should we move on or not?
Yes, sir.
Okay, good. Now, try to understand here what is the means of the absolute permittivity. Are you clear? Try to understand, and in the simple way, suppose that we are taking we are taking two charges. Are you clear? And both of the charges have, both of the bodies have 2 Coulomb charges. Okay. And separated at a 5-meter separation. 5 centimeter, you can say. And remember that these two charges are kept in air. Are you understand it or not? These two charges are kept in air. Are you clear? What is the medium between the two charges? This is air. Okay. And these two charges also have 2 Coulomb charge, and both are separated at 5 centimeter. But these are kept in the oil. Are you understand it or not? We have taken two different conditions in which the magnitude of charge and the separation between them are same, but the medium is different. Okay. In case 1, the two charges are kept in air, and in case 2, the two charges are kept in oil. Okay. Then you should remember that. The magnitude of force, I mean the force acting between these two charge bodies A and B. Okay. The magnitude of force acting between these two charge bodies always be different. Are you clear? Why? Because the medium of the two charge bodies are different. Are you clear? Are you clear or not?
Yes, sir.
We can say the magnitude of force acting between two bodies are also depends upon the medium in which the charges are kept. Are you clear?
Yes, sir.
Yeah. Okay. This is one of the simplest way to understand it. Okay. You can look at here value of epsilon naught. Okay. All of you are looking or not? Value of epsilon naught depends on the nature of medium. Are you clear or not? Nature of medium separating the charges. What is the nature of medium in case 1? The nature of medium is air. And what is the nature of medium in case of second? The nature of medium is oil. Are you clear? Okay. So we can say the magnitude of force acting between these two charge bodies also be different. Are you clear? Are you clear or not? Hello.
Yes, sir. Yes, sir. Clear.
Yes, sir.
Yeah, Matthew, do you understand it?
Yes, sir. I understand.
Yeah, what do you understand? Can you tell me, please?
Yeah, the magnitude charges between water and oil, they are different.
Okay. And now suppose that we are going to change oil to the suppose that we are taking 1 second any other media like kerosene oil. Okay, we are taking kerosene oil, and in second case we are taking in petrol or diesel. Okay, then remember that in these two different media the magnitude of the force also be different. Are you clear or not? Hence we can say that in overall the magnitude of force between two charged particles also depends upon the medium. Are you clear? Okay. Hello. Naval. Naval.
Yes, sir.
Can you understand it or not?
Yes, I understand.
Yeah. Zarsh.
Yes, sir.
Yeah. Can you understand it?
Yes.
Okay, good. And now the next point, what will happen in case of the CGS system? Remember that, just 1 second, we have a formula of the Coulomb's law. F is equal to K Q1 Q2 over R square. Okay, in SI system we have completed, and in second part in CGS system, then you should remember that in CGS system K always be 1, hence we can say the formula will be F is equal to Q1 Q2 over R square. Okay, this is the formula of the magnitude of the force between two charged particles in CGS system. Okay. And now some important point is also given here. Note, Coulomb's law, it is valid. Coulomb law is valid for static charges. Okay. In which condition the Coulomb law is valid? Static charges.
charges.
I means the charges should be in the state of rest. Okay. And the second points, magnitude of force, between two charged particles. Just 1 second. Okay, I am doing the short. In short, magnitude of force depends on nature of medium also. Are you clear or not? What is the means of nature of medium here? Anyone can tell me? What is the means of nature of medium here? I mean, in which medium, in what type of medium or in which medium the charges are kept. Are you clear or not?
Yes, sir.
Yeah. And the next point is electrostatic force. Electrostatic force is conservative in nature. It is conservative also. And the last point is Coulomb's law is valid. Coulomb's law is valid for static charge. Sorry, for point charge. Just 1 second. For point charge. Okay. Or you can also say static charge distribution. Okay. Please note it down. Should we move on? Hello.
Yes, sir.
Let's consider a question here. Please write down. Example. Or you can say a question. There are two bodies are kept in which Q1 is equal to 2 microcoulomb, sorry, 2 millicoulomb, not micro. And the second charge body is kept at some separation which is of minus of 3 millicoulomb, and both charges are separated from each other by the separation of 3 mm. Okay, what is the separation between the two charge bodies? It's 3 mm. Okay, please try to solve this. All of you can solve it or not? Hello, Alina.
Yes, sir.
Yeah, can you solve it or not?
No, sir.
Why? Let's see. What will be the solution? What is going? What is given here? The Q1 is of 2 millicoulomb, which is equal to 2 into 10 raised to the power minus 3 coulomb. What is the Q2? Q2 is of minus of 3 millicoulomb. It will be 3 into 10 raised to the power minus of 3 coulomb. What is the R? R is of 3 mm. It will be 3 into 10 raised to the power minus of 3 meter. Now, what is the formula? The formula F is equal to 1 over 4 pi epsilon naught Q1 Q2 over R square. It will be, what is the 1 upon 4 pi epsilon naught? The value of this is 9 into 10
9
raised
to
to the
10 raised
power
to
9.
9.
What is Q1? Q1 is 2 into 10 raised to the power minus of 3. Q2, 3 into 10 raised to the power minus 3 over R. R is 3 into 10 raised to the power minus 3 square. Okay. Please try to calculate this. It will be 9 into 10 raised to the power 9. 6 into 10 raised to the power minus of 6 over 9 into 10 raised to the power minus of 6. It is cancelled here. 9 is cancelled with 9. You got 6 into 10 raised to the power 9 coulomb. Okay. It will be your final answers. Sorry, not coulomb. It is Newton. Okay. It's Newton. Are you clear or not?
Yes, sir.
Yeah. Please note it down. Next question is, Have you noted it or not?
Yes, sir, noted.
Yes, sir.
Okay, good. Next question. This question is for all of you. Two charges Q1 and Q2 placed at a separation R repel each other with a force of F. With a force of F. Calculate force between them if magnitude of both the charges is doubled and separation between them is half. Okay, please note it down and solve it. All of you can solve it or not?
Yes, sir.
Okay, please try to do this. Answers, anyone can tell me, please? Anyone can tell me the answers? Zarsh, Nawal, Alina. Hello. Samson. What is the
I'm not
final
sure about
answer?
the answer.
What is the final answer?
I don't know the answer, sir.
Sorry.
I don't know the answer, sir.
Okay. Now let's try to solve this. In this question, you can see, then there are the, okay, in this question, if you can see, it is in two different parts. In the first part, it is saying that two charges Q1 and Q2 are placed at a separation of R, repel each other with a force of F. Then can you tell me what will be the relation between them? The relation will be F equal to K Q1 Q2 over R square. Am I right or not?
Yes,
This
sir.
is your equation number 1. And now in the second part, calculate the force between them. If the magnitude of both, just one second, please. Write such like this. In case 1, the charge Q1 is Q1, charge Q2 is Q2, and R is R. Then what will be the force? F is equal to K Q1 Q2 over R. In the second case, it is saying that magnitude of both the charges is doubled. This means Q1 is equal to 2Q1 and Q2 is equal to 2Q2. Are you understand it?
Yes.
Okay. And the separation between them is half. Then R is equal to R by 2. Okay. Okay. Then what will be the what will be the relation? F is equal to K 2Q1 into 2Q2 over R by 2 square. This is your equation number 1 and this is your equation number 2. Are you clear? Are you clear or not?
Yes, sir.
Yes, sir.
Then try to solve this. This will be F is equal to 2 into 2 is equal to 4. I am taking outside 4 K Q1 Q2 over R square over 4. After squaring R by 2, you got R square by 4. Okay. Then finally, this 4 will transfer, okay, from numerator to the denominator. You got F, sorry, take it F dash, okay, because we have taken F here in case 1. It will be 16 K Q1 Q2 over R square. What is the K Q1 Q2 over R square? This is your F. Am I right? This is your
Yes, sir.
F. Okay. Then we can write here also F dash is equal to 16 F. Are you clear? Are you clear or not?
Sir, can you
Yes,
explain
sir.
how we got 4
This
over
means,
there?
sorry,
Can you explain how we got 4 over there instead of K?
sorry, just
Yeah, there. How did you get 4? How did you get 4?
this 2 into
No.
2 after multiplying.
Oh, okay, fine.
Okay. And when this 4 is transferred from denominator to the numerator, it will be 4 into 4. Okay. This 4 into 4, it will be 16. Okay.
Okay, sir.
Yeah. Please note it down. This question is a very good question. Should we move on?
Yes, sir.
Okay, good. The last question on the Coulomb law is the another type of question. Okay, and I hope that all of you can solve it. I'm writing on the screen. Please note it down. Two charges of Q1 is equal to 2 mc, mc in the sense millicoulomb, and Q2 is equal to minus of 3 millicoulomb are placed at A. Point A is 2, 3, 1 meter, and point B is 1, 1, 0 meter. Calculate force on charge of minus of 3 millicoulomb due to 2 millicoulomb. Okay. Please try to solve this question. I hope the concept of vector is clear. Okay, to all of you. Do you remember the concept of vector? I cap, J cap, K cap. Do you remember or not?
Yes, sir.
Yeah, please try to solve. All of you can solve it or not?
Solving, sir.
Solving?
Yeah.
Okay, good. Please try. Please try to all of you. It's a very easy question. Please try to all of you, please. Zarj, Nawal, Alina, Samson. All of you can hear me?
Yes, sir, we can hear
Yes,
you.
sir.
Yeah, please try to solve. All of you are understanding this question or not? I hope no. Am I right? Alina, can you understand it? Yeah.
Yes, sir.
Let's see here. Okay, I am solving this question. Okay. point A is okay, showing the coordinate, I mean position of the charged particle, okay, in the space. How can you draw this in pictorial form? Suppose that this is your coordinate system. This is your coordinate system. And suppose that this is your position of A. Okay.
So z-axis also is there, right?
Yeah. Z-axis is also there, but on the plane 3D is I think impossible to draw. Okay.
Okay, sir.
Okay, just imagine that this is your point A. Okay. And the coordinate of the point A is 2, 3, 1. Are you clear? This is your I coordinate, this is your J, and this is your K. Are you clear? And the another point B is at this position. This is the point B of 1, 0. 1, I mean I. This is your J, and this is your K cap. And the charges are 2 millicoulomb, and the charges on B is minus of 3 millicoulomb. Okay. And what is the separation between them? Anyone can tell me? What is the separation between them? What is the separation between them?
K cap.
I think R1 is 2, 3, 1. Yeah. This is your R1. R1 is your, okay, take it like R1, and this is your R2. And the separation between them will be R2 minus R1. Are you clear?
Yes, sir.
Yeah. Then what will be the R1? R1 is 2I cap plus 3J cap plus K. And what is the R2? I plus J. Okay. I plus J. Are you clear or not? Then what
Yes,
will be
sir.
the R2 minus R1? R2 minus R1 will be R2 is your
I
I
cap
plus
2J cap.
minus and 2I plus 3J plus of K. It will be I plus J minus of 2I minus 3J, sorry, minus K, minus of K. In this case, what will be the I? I will be minus of I. You can look at here. This I is in plus sign, and this is your minus sign. Okay. So it will be minus of I. And what will be the J? It is a minus of 2J, and K is minus K. Okay. This is your R2 minus R1. Are you clear? This is your R2 minus R. I mean the separation between A and B is minus of I cap minus 2J cap minus K cap. Are you clear?
Yes.
And now what will be the force between these two bodies? All of the values are given in vector form. Okay. So the solution also be in the vector form. So first of all, we are going to calculate the force acting upon the charge B due to charge 1. Due to charge A. Okay. So it can be written here F of 2, which is equal to the 1 upon 4 pi epsilon naught, and Q1, Q2 in vector form it is R2 minus R1 over R2 minus R. Just one second. I think all of you can confuse here. Q1, Q2 over R2 minus R1 into unit vector. Are you understand about the unit vector? Why we are taking here the unit vector? Because we are going to calculate the magnitude of the force between these two charged particles in the vector form. Are you clear or not? And force is a vector quantity. Okay. So we can also write here F is equal to 1 over 4 pi epsilon naught Q1, Q2 over R2 minus R1 in the vector form. And what is the n vector? N vector is of vector of R2 minus of vector of R1 over mod of R2 minus R1. Finally, you got F is equal to 1 upon 4 pi epsilon naught Q1 Q2 R2 minus R1 over R2 minus of R1 of power 3, because the power is 2 power is here and the power of R2 minus R1 is 1 here. Okay, so the total power will be 3. Okay, please note it down, then we will move on. Note it down, please. All of you noted it or not?
Noted, sir.
Yeah. So we got a formula in the vector form. F is equal to 1 over 4 pi epsilon naught Q1 Q2 R2 minus R1 over R2 minus R1 power 3. Okay. What is the value of 1 over 4 pi epsilon naught? It is 9 into 10 raised to the power 9. And what is the value of Q1? Remember here, Q1 is your 2 millicoulomb. It
2
will
into
be
10 raised to minus
power
3.
minus 3 coulomb, right? What is Q2? It is a minus of 3 millicoulomb. It will be minus of 3 into 10 raised to the power minus 3 coulomb. Okay. So, right here, value of Q1, 2 into 10 raised to the power minus 3 into 3 into 10 raised to the power minus 3, because minus sign is, okay, there is no need to consider the minus sign in the formula. What is the R2? What is the R2? R2 is I plus J minus R1. R1 is your 2I plus 3J plus of K okay, over R2 minus R1. R2 minus R1 we have already calculated. This is your minus of I minus 2J minus K. Okay. So R2 minus R1 is minus of I minus 2J minus K. Just 1 second. Yeah. So I am writing here minus of I minus of 2J minus of K power 3. After solving it, you got, please try to solve this. Okay. Please do the calculation. It is 9, 10 raised to the power 9. 2 into 10 raised to the power minus of 3 into 3, 10 raised to the power minus 3. And this will be I, sorry, not I, R2. Minus of I plus 3J. Yes, R2 minus, yes. We are taking a negative sign also here. Okay. So the negative sign we are taking here. Minus of I, minus of 2J and minus of K. After multiplying this minus sign, it will be plus of I plus 2J plus K. Okay. Over root of minus of 1 square, minus of 2 square, and minus of 1 square of the power 3. It will be 54 into 10 raised to the power 3. Look at here, 9 into 2 into 3. What will be the 9 into 2 into 3? It will be 54. Are you clear or not? So I have already
Yes,
written
sir.
as 54 into 10 raised to the power minus 3, 10 raised to the power minus 3. It will be 10 raised to the power minus 6 and 10 raised to the power 9. It will be 10 raised to the power 3. Okay. In the bracket, I plus, no. Just 1 second. It is a 3J, not 2J. Okay. Plus 3J and plus K over 6 root of 6. When you subtract, when you cancel 6, 54 by 6, it will be 9. And finally, you got the 9 into 10 raised to the power 3, I plus 3J plus K over root of 6 Newton. This is your F of 2-1. Okay. And from action reaction law, you can also say the F of 1-2. F of 1-2 will also be 9 into 10 raised to the power 3, I plus 3J plus of K over root of 6 Newton. Please note it down. This is the final answer. Okay. All of you are understanding this, okay, this calculation or not?
Yes, sir. The final answer is F21 or F12, sir? Or both?
Both are the final answers. Okay. I mean the force
Yes,
acting between these two bodies, okay, always be same. Am I right or not?
Yes,
According
sir.
to the action reaction law. Okay.
Okay, sir.
Yeah. Matthew. Matthew, are you understand it or not?
Yes, sir, I understood it.
Is it is
What-
clear?
Yeah, it's clear, sir.
Samson, Nawal, Alina,
I can understand.
all of you are understanding?
Yes, sir.
Okay,
Yes,
good,
sir.
good. Zarsh,
Yes, sir.
are you understand it or not?
Yes,
I
sir.
think it's your first class, am I right?
Yes.
Oh, yeah. Okay, are you understand it?
Yes.
Do you know about the electric charges? I mean, fundamental of charges.
Yes, sir.
Okay, all right. Zarsh, I will give you the backup class, okay, on another day, right?
Okay, thank you, sir.
Yeah, sure. Now all of you have, okay, noted it. Can we move on?
Yes, sir.
Yeah, good. The next heading is dielectric constant and the relative permittivity. Okay. The next heading is dielectric constant and relative permittivity. Okay. So please note down what is the means of the permittivity. What is the means of the permittivity? I have already told you that what is the means of the permittivity. Permittivity told us, or you can say the permittivity determines, okay, permittivity determines the magnitude of electric force between the medium. Do you remember or not? Hello.
Yes, sir.
Yes,
Yeah,
sir.
what is the means of the permittivity? We have already studied in the Coulomb's law. Do you remember or not? What does the permittivity decide? What is the significance of the permittivity? It gives the magnitude, it determines magnitude of electric force between the medium. Are you clear?
Yes, sir.
Yeah.
Yes,
So
sir.
please note down the definition of the permittivity first. Okay. Permittivity. Write down here. Permittivity determines the magnitude of force, between two charges in medium. Are you clear? Are you understand it? What is the role of the permittivity? It determines magnitude of force between the charges in medium. Are you clear?
Yes, sir.
Yes, sir.
Yeah. Now, according to the Coulomb's law, we have already know, according to the Coulomb's law, in vacuum or air, what is the force? F will be this zero. Zero is also called naught. Okay, zero is also said to be the naught. So we can pronounce it F naught, or you can also say F0. Are you clear? Which denotes
Yes,
the
sir.
force between the vacuum or air. Okay, it will be 1/4 pi epsilon naught magnitude of Q1, magnitude of Q2 over R square. It is your equation number A. You can also write. Also make a charge particle like this. 1 second. This is your charge. These are the two charges. Okay. And the separation between them is R. This is your R. This is your Q2 and this one is the Q1. Okay. Q2 and Q1. Are you clear till here?
Yes.
Okay. F naught is 1 over 4 pi epsilon naught Q mod of Q1 mod of Q2 over R square. Okay. And now, what is the epsilon naught? Can anyone tell me? What is the epsilon naught?
Permittivity of free space.
Exactly. Which is in case of here, it is called absolute permittivity. Okay. In case of here, it is said to be the absolute permittivity. Okay. Of free space also. And now, can anyone tell me what will be the formula of the Coulomb's law in case of medium? When the charges are kept in medium? 1 second. Yeah. What will be the equation in medium? F of, we can write like M. Okay. Fm denotes the force in the medium, which is equal to 1 over 4 pi. Now we are taking not, okay, now we are writing epsilon only. What we are, okay, written here, epsilon. Okay. This is your epsilon. We are not writing here 0 or not, because it denotes for the vacuum or air. Are you clear? But
Yes,
in this
sir.
case, we have taken a medium. You can look at here in the heading. We have taken a medium. So for the medium, the permittivity denoted by epsilon only. In case of the permittivity in case of air or vacuum is denoted by epsilon naught. Are you clear or not?
Yes, sir. Clear.
Yeah. Epsilon mod of Q1 mod of Q2 over R square. This is your equation number B. Okay. What is epsilon? Epsilon is absolute permittivity of medium. Okay. Please note it down.
Done, sir.
Good. And now we have two different equations. The first equation of the force in air and the second equation is in the medium. Okay. So please note down here. I am removing some part. Now, from equation A and B, okay, or you can also say from equation A is divided by B, okay. What we get here, one second. Now take the next page, sorry. From equation A is divided by B, okay. What we get here, what is equation A? This is your F naught over Fm is equal to 1 over 4 pi epsilon naught over 1 over 4 pi epsilon, 4 pi epsilon, and this is your Q1, Q2 over R square, and this is your Q1, Q2 over R square. This is totally cancelled with each other, and 4 pi is cancelled with 4 pi. You got F naught over Fm is equal to epsilon over epsilon naught, okay. And this epsilon naught over epsilon naught is also known as K or ER. ER in the sense relative permittivity, okay. So you can write here E over E naught is equal to K or ER. What is the ER? ER is said to be the relative permittivity, and or K is known as the dielectric constant, okay. Dielectric constant. Are you clear? This is your equation also. And let's consider equation C, okay. Or you can also write E is equal to K, epsilon is equal to K epsilon naught, okay. This is your equation D. Now, on substituting, the value of equation D from equation B, then Fm, what will be the Fm? This is your equation, okay, D and C, okay. Please note it down first, okay, then we will do this part. First of all, please note it down. Have you noted it?
Yes, sir.
Yeah. Now from this equation, this one is equation, you can also write F naught over Fm is equal to K, or Fm is equal to F naught over K. Okay. Also note it down. Then write. Please note it down. Can we move on? Hello? All of you
Yes,
have
sir.
done
Yeah.
here? Yeah. And now we got an equation of D. Okay. You can look at here. D. In the equation D, you can look that epsilon, the value of epsilon is equal to K epsilon naught. Okay. Now we are going to substitute this equation D from equation B. What is your equation B? The equation B is this. Okay. First of all, I am writing equation B here on substituting the value of equation D from equation B. Okay. What is the value of, what is the equation B? Fm is equal to 1 over 4 pi epsilon mod of Q1 mod of Q2 or R square. What is the value of epsilon from equation D? Put here. Fm is equal to 1 over 4 pi. Epsilon is K epsilon naught. Q1, Q2 over R square. Also note here the value of epsilon is K epsilon naught. Okay, from equation D, right? So Fm will be equal to, this is also fine here. 1 over 4 pi K epsilon naught Q1 Q2 over R square. Okay. Where you can also write the value of K either be greater than or the value of K either be greater than or equal to 1. Okay. Please note it down. Have you noted it?
Yes, sir.
Okay. Now also mention here the value of K is equal, sorry, the value of K is 1 for air. 1 second. Yeah, please note it down. The value of K is 1 for air. Value of K is 80 for water. And the value of K is infinite for conductor. Okay, please also note it down. Have you noted it?
Yes, sir.
Yeah. And now once again, we are coming upon this equation. From this equation, we can say the dielectric constant, or from this equation, not this equation. Yeah, from this equation and this equation, we can say the dielectric constant, or relative permittivity is the ratio of the force between two charges in vacuum to the force between some charges in medium. Please note it down, this part. Okay. Have you noted it?
Yes,
Yes,
sir.
yes, sir.
And now today, okay, we are going to over this class, all right, and we will meet in our next class on Wednesday, right?
Yes, sir.
Yeah. All of you are totally understanding, okay, in the today's class or not?
Yes, sir. Understanding.
Anyone?
Yes,
Anyone else? Anyone which have any issues can tell me, please. All of you are comfortable?
yes, sir.
Yeah. Okay. Okay. Okay.